So let's go on to the next topic today, thermodynamics का. We are just approaching the end of this chapter over here. हम लोगों ने first law of thermodynamics किया था और first law of thermodynamics के accordingly we did enthalpy, we did energy, we've done enthalpy changes क्या होते हैं. So everything which we did, and one major thing which we understood when we did all the chapter was कि जब भी delta H negative होगा, in that case what is going to happen? The reaction that is going to go in the forward direction. Right? So over here, when we talking of limitations of the first law of thermodynamics, first law of thermodynamics हमें क्या बोलता है? Delta U that is equal to Q plus W. Now the change in internal energy will take place if there is certain change in heat in a system or there is certain work done by the system or done on the system. Only then the internal energy that is going to change. So let's today understand what are the limitations of first law of thermodynamics. Limitations. When we're doing the limitations of first law of thermodynamics, it does not give us any information about the direction of any reaction. ठीक है कि reaction जो है वो किस direction में जा रही है, कि किस direction में यहाँ हम बोल रहे हैं कि किस direction में flow of heat हो रही है या किस direction में क्या कहते हैं, it just says कि भाई okay the heat that is flowing. मतलब कि जब हम लोगों ने कैलोरीमीटर भी किया तो उसमें हम लोगों ने क्या किया कि the heat that was flowing from one part to the other part. So there is no direction of heat that has been given according to the first law of thermodynamics, right? Now, in order to predict the direction of the flow of heat, one more parameter is required, that is temperature. So it's not only the direction of heat that can be explained on the fact of another parameter, which is temperature. Because if you're looking at the first law of thermodynamics, तो वो बोल रहा है delta U is equal to Q plus W. Okay, so वो सिर्फ बोल रहा है कि heat is flowing. अब heat किस direction में flow करेगी वो depend करेगा किसके ऊपर? Temperature के ऊपर. Heat will flow only from higher temperature to lower temperature. ठीक है? So this is not told by the first law of thermodynamics. Second चीज जो इसकी limitations है, it does not explain why chemical reactions do not go to completion. कि why any chemical reaction that is not going towards the entire formation of products. ठीक है? Then number 3, this law does not explain why the natural spontaneous processes are any natural spontaneous process, they are irreversible. जैसे for example, if we have kept ice on a table, this is a natural process that ice that is going to melt into water. ठीक है? So naturally spontaneous जो reaction रहेगी, that is from ice to the water in the liquid state. But it does not tell us कि why water cannot be converted into ice. So it will only natural spontaneous processes जो है, they are going to be irreversible. So the first law of thermodynamics is unable to explain this statement. ठीक है? Then number 4, it does not contradict the 100% efficiency of any machine. We know that none of the machines they show 100% efficiency. So according to first law of thermodynamics, any machine, or we are saying whenever any mechanical change is taking place, the efficiency should be 100%. But in practicality, it is seen that none of the machines they show 100% efficiency, so it does not contradict this statement. ठीक है? And finally, the differences between spontaneous and non-spontaneous processes. Spontaneous processes वो होते हैं which are going to the forward direction on their own. So according to first law of thermodynamics, spontaneous and non-spontaneous processes, they do not have any significance. These terms, they are going to have no significance according to the first law of thermodynamics. ठीक है? Now when we're talking of this term over here, spontaneous and non-spontaneous process, let's understand what do we understand or what do we mean by spontaneous and non-spontaneous process. It is said that whenever we are talking of the term spontaneous का मतलब क्या हुआ? A reaction that occurs under set of given conditions, that is said to be spontaneous. That any reaction which is going to go into the forward direction, that is going to be a spontaneous reaction. There are several examples. For example, one example which we can take over here is that we have a ball and we're standing on the top of a you can say on the top of a flare of steps. वहां से अगर हम लोग उसको बॉल को किक करेंगे तो क्या होगा? बॉल नीचे जाके अपने आप स्पॉन्टेनियसली गिरती रहेगी, ठीक है? पर जब हम लोग उस बॉल को वापस किक करने की कोशिश करेंगे, the ball will not go at the top of the step. So the process in which the ball that is rolling down, that is a spontaneous process, and the process in which we are putting energy to take the ball back to the क्या कहते हैं उसको, back to the upper flare of the steps, that is going to be non-spontaneous. ठीक है? Similarly, we've taken one example over here that ice will spontaneously convert into a liquid, whereas liquid will not spontaneously convert into ice. So ice into water, that is going to be a spontaneous process, whereas water into ice, that is not going to be a non-spontaneous process. Then we have other many examples. For example, if you've taken salt, a pinch of salt, you put it in water, what will you see? That after a little while that salt that is going to disappear because that is entirely dissolved into the water. So that is a spontaneous process. Is it clear? Similarly, if we are looking at any rock which is placed at the top of the cliff, उसको भी अगर हम धक्का मारेंगे वो नीचे जाके गिरेगा. So that is also a spontaneous process. We've kept water in any container, say एक कटोरी ली है उसके अंदर हमने पानी डाला है. After a little while we will see that there is no water which is left in the container. It means all the water that is evaporated to the gaseous state. So this is also what? This is also going to be a spontaneous process. So these are what spontaneous processes and non-spontaneous processes are. Now we say that basically when we are talking of spontaneity of a reaction, we come to another term जिसे हम बुलाते हैं feasibility of a reaction. Any spontaneous reaction that is going to be feasible. Feasible means that it will go towards the product side. अब spontaneous का when we talking of spontaneous reactions over here, it does not mean that these reactions are instantaneous. Right? It does not mean that the reactions they are going to be instantaneous. मतलब कि the reactions may proceed at a very slow rate. Like for example, if we are taking rusting of iron is a spontaneous process, but it might take few months to few years for the iron to rust. ठीक है? Similarly, we say that a spontaneous process is that if we are okay, we've taken wood, ठीक है, और वुड को अगर हम लोग जब तक इंस्टिगेट नहीं करेंगे, उसमें आग नहीं लगाएंगे, it is not going to burn. So once it is initiated, it will keep on burning. So that is also a spontaneous process, but it is not an instantaneous process. So it is a slow process. But there might be certain examples in which the processes may be instantaneous. For example, the न्यूट्रलाइजेशन रिएक्शन में हम लोग क्या देखते हैं कि जैसे ही हम कोई एक एसिड लेते हैं और उस पे हम बेस डालते हैं, immediately it is going to be converted into salt plus water. So this reaction just takes place with a flick of a time. So that is why this is an instantaneous, spontaneous reactions. So spontaneous reactions may be slow, they may be very slow, and they may also be quick. They may be instantaneous. Okay. Now all natural processes which are going to be spontaneous, they are going to follow a non-equilibrium path and as such are irreversible. So jitne bhi spontaneous processes honge, they are going to be irreversible, which means that ice to water is spontaneous, but liquid to or water to ice, that is non-spontaneous. So this process is going to be irreversible. In order to change liquid into ice, we have to change the conditions for it to happen. So we say that there are many reactions which are spontaneous, which are irreversible, which do not go to the state of equilibrium. The state of equilibrium is going to be attained only by changing the set of conditions. ठीक है? जैसे for example हम यही वाला example ले रहे हैं, we are taking H2O solid to H2O liquid, right? So what we have to do over here is, if we have to make this reaction reversible, so जो आगे होगा that is going to be a spontaneous process. But in order to make it change back into solid, we have to decrease the temperature to 0 degrees Celsius. So an equilibrium may be attained if we are changing the set of conditions. ठीक है? So this is going to be spontaneous and non-spontaneous reaction. So what is the force which is taking any reaction or which is telling us that the reaction is spontaneous? Let's go on to the driving force to spontaneity. What is the driving force reaction? What is the driving force for a spontaneous reaction? Now it is generally says that the force which is responsible for the spontaneity of a reaction, that is known as the driving force. And it is generally seen that lesser the energy of the system, more is the stability. Right? Energy is inversely proportional to stability. If the system has less energy, it is going to acquire more stability. So every system has a tendency to possess lesser energy. That can only be done for exothermic reactions. So it is generally seen that the driving force of any reaction is its capability to lose energy, and this can happen in exothermic reactions. So there are many reactions. For example, we are taking H2 plus half of O2 to give us water. Delta H for this, that is equal to minus 286.2. So this is going to be a spontaneous reaction. Similarly, if you are taking carbon, combustion of fuels, carbon plus oxygen to give us carbon dioxide. Delta H in this case, that is equal to minus 393.5 kilojoules per mole. So this is also going to be a spontaneous reaction. Similarly, we come to another reaction, N2 plus 3H2 to give us 2NH3. Delta H for this reaction, that is also seen to be negative of the order of minus 92.4 kilojoules per mole. So all these reactions, as we see, the reactions are exothermic, as a result of which they are losing energy and hence they are going to become spontaneous. But there are certain limitations to the first condition which we are discussing over here. It is not essential that all exothermic reactions are going to be spontaneous, and all endothermic reactions, they are going to be non-spontaneous. There are many endothermic reactions which are spontaneous in nature. So So if we're looking at the limitations of this driving force, energy as the driving force, the first limitation over here is that many reactions, many endothermic reactions they are also going to be spontaneous. For example, if we have water in the liquid state, it will spontaneously convert into water in the gaseous state, and delta H for this, that is going to be positive. Okay, so this is an endothermic reaction which is taking place. Similarly, if we are taking calcium carbonate in the solid state, now calcium carbonate at room temperature does not decompose. ये lime है, limestone है, उसको आपने ऐसे जैसे this is limestone ऐसे ही रखा हुआ है, it is not going to decompose. So it will only decompose on heating into calcium oxide and carbon dioxide. तो इसके लिए भी जो delta H है, that is going to be positive. ठीक है? Similarly, we can take another reaction over here. If we are taking ammonium chloride and we are trying to dissolve it in water, this is solid. So if you are dissolving it in water, aqueous, it will only dissociate into its respective ions on heating. So we have NH4 positive, aqueous plus Cl negative, aqueous. Delta H for this reaction, that is also positive. Okay? So the first limitation is that it is not always true that all exothermic reactions are spontaneous and all endothermic reactions are non-spontaneous. Okay? So there are many examples of endothermic reactions which are going to be spontaneous. Second is occurrence of reversible reactions. This is the second limitation. There are many reactions which may be exothermic in the forward direction, but they are endothermic in the reverse direction. Okay? Just for example, if you are taking the formation of hydrogen iodide over here. Okay? In this case, this reaction that is going to be exothermic as delta H for this reaction that is negative. But if we are taking a reversible reaction over here, that is the decomposition of hydrogen iodide to give us H2 plus I2, delta H in this case, that is going to be positive. So both the reactions, they are going to be spontaneous. Reactions which are exothermic in the forward direction may be endothermic in the backward direction. Okay? Similarly, if we are taking another reaction we are taking over here, if we are taking the manufacture of ammonia, 3H2 to give us ammonia, we already know that delta H for this reaction, that is negative. Right? But if we are taking the reverse reaction, that is decomposition of ammonia to give us N2 plus 3H2, delta H for this, that is going to be positive. Is it clear? So delta H negative in the forward direction and it is going to be positive in the reverse direction. Then there are many reactions which have zero enthalpy change. Reactions with delta H equal to 0. These reactions may also be spontaneous. For example, if we are taking the esterification reaction of acetic acid and C2H5OH to give us CH3COO, C2H5 plus water. Now the enthalpy change for this reaction, that is equal to 0, but still it is seen that the reaction that is spontaneous. So there should be some other reason as the driving force other than the energy changes. So what is going to be this second reason? The second reason is the reason that every system wants to, or the tendency of every system to acquire a state of randomness. What do we understand by this term which we are using over here? Randomness. Randomness का मतलब होता है disorderedness. To go into a disorderly arrangement so that they can easily move. For example, when a solid is getting converted into liquid, in case of solid, the molecules they are very tightly packed. ठीक है? So as a result of which they are all present in a disciplined manner. अगर उसको हम लोग solid को पड़े रहने देंगे, तो क्या होगा? It will get converted into liquid at a higher temperature. So liquid with the molecules they are going to go far apart. As a result of which the degree of randomness that will increase, or they will become more disordered. So every person also, for that matter, as us also as human beings, we have a nature of getting disordered because we feel free in that, isn't it? If suppose we are having an assembly in which you must be knowing, जब आप छोटे थे तो क्या होता था कि एक assembly हो रही है स्कूल की, तो उसमें आपको बोला है लाइन में खड़े हो जाओ, तो एक जो फ्रंट वाला बच्चा होता है वो ऐसे 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 करता रहता है ना, एक सिंगल लाइन में, एक सिंगल रो धूप दिख रहा है पीछे हो जाओ, सो ऐसे करके, that is a disciplined manner, right? Now everything has been said. The assembly students they are all standing in their lines in attention. Okay. Now accidentally अगर कोई एक बच्चा जाके उसी वक्त छुट्टी की बेल बजा देगा तो क्या होगा? They will start moving here, there, everywhere in the playground. So that is what disorderness is, and everybody likes to be free. So same is happening with the molecules over here. The molecules love to be free. So they go from an ordered arrangement to a disordered arrangement, and that is what randomness is. ठीक है? Now let's say okay, so what we are doing over here, we are taking two gases just to illustrate this. दो gases हम लोगों ने ले ली इस तरह से, we've taken a stopcock over here and we have taken one gas over here, right? And we have another container, और इसमें भी we've taken another gas. ठीक है? So let's see कि यहाँ पे हम लोग जो gases है उसके molecules ऐसे hollow circles के साथ show कर देते हैं, और यहाँ पे जो molecules हैं उसको हम bold के साथ show कर देते हैं. Now as soon as we are going to open this cork, what is going to happen? Intermixing of gases that is going to take place. So they are going from an orderly arrangement to a disorderly arrangement. This is going to be a spontaneous process. So we say that diffusion of gases is a random process. Why? Because randomness over here that is going to increase. Okay, so generally spontaneity क्या हुई? To move from an ordered arrangement to a disordered arrangement. That is what spontaneity is. So the second factor which is going to be responsible for any spontaneous reaction is increase in randomness or increase in disorderness. So now we have two factors over here. One is the energy factor for any reaction to go into lesser energy. And the second one, that is randomness. Now sometimes it so happens that only one factor is unable to explain the spontaneity of a reaction. कि सिर्फ अगर हम exothermic reactions ले रहे हैं तो we've already seen कि सिर्फ exothermic reactions ही spontaneous नहीं होते. Secondly, if you are taking only the disorderly arrangement, sometimes even only the disorderly arrangement will not take a reaction to be spontaneous. So we have to take the net result of both exothermic reaction, that is decrease in energy number one, and number two, the randomness of a reaction. Now this randomness of a reaction, that is going to be what? That is going to be measured in terms of a certain factor, and this factor we will just study, that is known as entropy. Okay, now as the exothermic reactions had certain limitations, in a similar manner this also has certain limitations. That is, for example, if we are doing the liquefaction of a gas. So what are we doing? Liquefaction of a gas is a spontaneous process. It can be done by decreasing the pressure. Increasing the pressure and decreasing the temperature. So liquefaction of a gas में तो क्या हो रहा है? Gas जो है वो ज़्यादा disorderly arrangement है और liquid जो है वो कम disorderly arrangement है. But हम लोग ज़्यादा disorderly से या ज़्यादा random से कम random की तरफ को आ रहे हैं. ठीक है? So this is going to be a limitation. Similarly, we are converting a liquid into a solid by decreasing the temperature. So उसमें भी liquid is going to be more random and we are coming back to the solid state which is less random. So that is going to be the limitations. So let's now understand what is the overall tendency as driving force for any spontaneous process. Overall tendency as driving force for any spontaneous process. For a spontaneous process. Okay. Now when we are looking at the overall tendency, it is seen that a spontaneous may, as I just told you verbally, that a spontaneous process may occur due to the following reasons. Number one, tendency of any system to attain a state of minimum energy, ठीक है, and tendency of any system to attain a state of maximum randomness. ठीक है, so ये दोनों है resultant जो होंगे इन दोनों के, that is going to be known as the driving force. So let's discuss a few cases over here. We are discussing case 1. According to the first case, when enthalpy factor is absent, as we just saw that delta H is going to be 0. When there is no enthalpy factor which is present, if delta H that is taken to be 0, in that case the randomness factor that is going to decide the spontaneity of a reaction. The randomness factor that will decide the spontaneity. ठीक है? Similarly, case 2 में, if randomness factor is absent, randomness factor that is going to be absent. ठीक है? So in that case, what is going to decide the spontaneity? The value of enthalpy change that is going to decide the spontaneity of a reaction. Right? And if both, let's take case 3. If both the factors are present, right? So in that case, magnitude of tendency of both randomness and enthalpy that is going to become important for us. So in this case, we are taking delta H and we are also taking randomness. Both have to be taken. The magnitude of both is going to decide the spontaneity of a reaction. So as I just told you that we come to another term over here which is known as entropy. Entropy is denoted by S. Right? So what is entropy? Entropy is the degree of measurement of randomness or disorderliness in a reaction. It is the degree of measurement of disorderliness of a reaction. That is what entropy is. Now over here, entropy it is represented by S as I just told you, and if we are taking the change in entropy delta S, that is going to be S final minus S initial. So if we are taking a reaction over here, reactants to products, then delta S for the reaction, that will be equal to Sp minus Sr, where Sp is the entropy of the products and Sr, that is going to be entropy of the reactants. So if we are talking of mathematical definition of entropy, if you're talking of mathematical definition of entropy, in that case it is defined as the integral of, you can write down, it is defined as the integral of all terms involving heat exchanged divided by the absolute temperature during each infinitesimally small change of the process carried out reversibly at constant temperature. So what are we saying over here? We are taking the integral of ds, infinitesimally small change in entropy, that is equal to 1 by T, infinitesimally small change in heat during any reversible process. This is how we have defined, we have done the mathematical definition. Small change, infinitesimally small change in Q. Okay? So this can be written as what? Delta S, that is equal to Q reversible upon temperature. This is an important expression for your competitions. इसमें से question आता है आपको, right? There are going to be several factors which are influencing the entropy. Let's see what are those factors influencing amount of entropy. Influencing amount of entropy. The first factor is that it is going to depend upon the mass. Therefore, it is going to be an extensive property. Entropy is an extensive property. Number 2, liquid has higher entropy. This we have already studied, so we are just summing up. Liquid has higher entropy than solid. Okay? Similarly, we will say that gas has higher entropy than liquid. So the order of or the disorderedness or randomness, that is going to increase in this manner. Now, whenever we are increasing temperature, what are we doing? It is going to increase the kinetic energy of the molecules. The molecules will start moving more randomly. Therefore, increase in temperature is going to increase entropy. So, as and when we are increasing the temperature, the entropy, that is going to increase. The reason, as I told you, more heat any system that is going to absorb. As a result of that, what will happen? The kinetic energy of the molecules will increase. They will start moving with randomness, with a higher speed, as a result of which randomness will increase and thus entropy will also increase. Now, what are going to be the units of entropy? As it is an extensive property, so आप देख रहे हो यहाँ पे joules per Kelvin, ठीक है? Q की आ गई joules, ऐसा यूनिट हम कर रहे हैं joules per Kelvin. As it is an extensive property over here, so we are going to take per mole. So the SI unit of entropy is joules per Kelvin per mole. So now let's understand spontaneity on the basis of entropy. Right? it is seen that mixing of gases, that is going to increase randomness, as we just said that diffusion of gases where randomness is going to increase. Therefore, entropy will also increase. Okay? In a similar manner, for a spontaneous system, it is said that the value of change in entropy should always be greater than 0. Or in other words, for spontaneity of a reaction, delta S should always have a positive value. Okay. In other words, we can also say that delta S, that is equal to S of system, entropy of system, plus entropy of surroundings, which is going to be greater than 0. Right? So S total is going to be equal to what then? If you're taking this as S total, system plus surrounding, that is equal to universe. So delta S total, that is also equal to delta S universe. Is it clear? So delta S total, that is equal to delta S universe. Now whenever there is a spontaneous process, the entropy of a system, that will keep on increasing. Okay, till the system attains equilibrium. So what is going to happen at equilibrium? Rate of forward reaction, that becomes equal to rate of backward reaction. Okay, that is what equilibrium is. So entropy of a system will become maximum when till the point of equilibrium has been attained. The entropy, that will keep on increasing. So equilibrium tak entropy jo hai, that is going to be maximum. Okay? So after that there is going to be no change in entropy. Once the equilibrium state has been attained, there is not going to be any change in entropy. This you need to remember, because this is the kind of conceptual questions which come in the competitions. Okay? So once initially when we begin the reaction, the entropy, that will keep on increasing. Once the equilibrium has reached, entropy has reached its maximum value, henceforth it will not change. Okay? So let's say that at equilibrium, what are we saying? So at equilibrium, what are we saying? That at equilibrium, the value of delta S, that is going to be equal to 0. So we come to two conditions over here. If the value of delta S, that is negative, the process is going to be non-spontaneous. Okay? If the value of delta S is positive, the reaction, that is going to be spontaneous. Okay? And if delta S is equal to 0, then in that case it is at equilibrium. So let's illustrate this by taking the example of water being converted into ice. So we are taking over here temperature in Kelvin, right? Then we are taking delta S of a system. The system over here is going to be water. We are taking delta S of surrounding. Okay? And we are taking delta S total over here. Right? Let's say we are taking a temperature of 272 Kelvin. This is going to be below 0. Okay, 272 Kelvin. It is seen that delta S, that is equal to minus 21.85. Okay, and delta S surrounding, that is equal to plus 21.93. What is going to be delta S total? Surrounding plus system. Okay, so delta S total over here, that comes to plus 0.08. Then we go on to a temperature. We've increased the temperature to 273 over here. At this particular point, delta S system that is equal to 21.99 minus, and this is equal to minus 21.99. So what is going to be delta S total? It will become equal to 0. Okay? Then we still increasing the temperature at 274 Kelvin. At 274, the value of delta S system that is minus 22.33, minus 22.13. Okay? And plus 22.05. So S total in this case that becomes equal to minus 0.08. Clear? So what are we getting from this is, we are getting that in case of temperature at 272 Kelvin, delta S is 0.08. So the conversion of liquid water to ice, H2O liquid to ice, this is going to be spontaneous. Why? Because the value of delta S total over here, that is equal to plus 0.08. It is positive. But when we are going at 273, this is the state of equilibrium. Okay, we know that melting point is defined as what? It is the temperature at which both liquid and solid state coexist. That is what the melting point is. So this is going to be, because the value of delta S यहाँ पे 0 आ रहा है, so that is why this is the state of equilibrium. And when we are going to the last one at a temperature of 274, the reaction that is going to be non-spontaneous. The ice is not going to freeze above, or water is not going to freeze above 273 Kelvin. Okay? So this is what we are trying to explain over here. The difference between spontaneous and non-spontaneous process on the basis of measurement of entropy. So whenever delta S is going to be positive, the reaction is going to be spontaneous. If delta S is 0, the reaction is at equilibrium, and if delta S that is equal to negative, in that case the reaction that is going to be non-spontaneous. Okay? So today we are going to do only till here.